All right, in this video, I'm going to cover some exercise problems in 7.1 and 2. Okay, so we'll see. I'm gonna cover 3 problems. Okay, so as you can see that first 7.2.5, and next one reserve problems 7.1.2, and then reserve problem 7.2.1. Okay. So, first one, let's see, 7.2.5. A normal population has a mean 100 and variance 25. So it means that the population um, is normally distributed with a mean 100 and then sigma square, right? Sigma variance, sigma square is 25 and the mu is 100. So how large must the sample size be if we want the standard error of the sample average to be at most 1.5. So the question is this: the what's the value of n, sample size n, uh, to have the mean of sample mean? The standard error of the sample average means the mean of the sample mean. I mean, error of the mean of sample mean is at most 1.5. So the sample size is integer value. Okay. So let's see, back to this quiz paper right here. So right. Okay, give me a second. Okay. All right, so we're gonna use the center limit theorems, right? Right. So center limit theorem says that if the population normally distributed, then the mean of sample mean is normally distributed, right? Okay, that's the center limit theorem. Or even, I mean, even though the population is not normally distributed, if sample size is greater than or equals 25, then the mean of sample mean is approximately normally distributed. Okay, so that's the center limit theorem. So for detail, just look at the textbook or my lecture note. Okay, so give me a second. Let me change. Okay, so problem says that what mu 7.2.5, right? Okay, so problem says that mu is what 100, right? And then sigma square is 25. Uh, Now, the center limit by CLT, center limit theorem, says that what? The sigma x bar, that's the mean of sample mean, okay? So this is equal to sigma over square root of n, okay? So here, n is what? N is the sample size. All right, so now then from here, we're gonna, what? Because we want, the question is to find out, give me a second, let me change, it's so blurry, right? So in this problem, question is to find out n, right? Satisfying the error of the mean of sample mean is at most 1.5. So okay. So now then, the n from here. Okay. So we're gonna solve that equation for n. Okay. So now n is equal to. So I mean, the n gonna be sigma. Oops. Sigma over a sigma x bar and the square, isn't it? Okay. So I switch the sigma x bar and square root n and take a square on both sides. So we're going to get this. So now this is equal to, by the way, sigma is what? Sigma is the square root 25, which is 5, right? The sigma x bar, okay, is what? The 1.5. Does it make sense? I told you, the standard error of sample average, it means the mean of sample mean. Okay, so that's the sigma x bar. Okay, so take square. Okay, so now then, oh sorry, this is the sigma x bar. Yeah, so this is sorry, this is the what the sample uh, the sample standard deviation. So deviation of mu x bar. Okay, so here mu x bar is the mean of sample means. Okay, sorry. Okay, so the problem says that standard error of the sample average, that's the standard deviation of the sample mean of sample mean. Okay, so sigma x bar standard deviation of mu x bar. Okay, so the sigma x problem says that what that means sigma x bar is 1. At most 1.5. So I plug in 1.5 into sigma x bar, so we're gonna get this. So now that is equal to yeah, just calculate it. Okay, so it's not a big deal to calculate this one, right? So let me move to the next problems. And then next one, the let's see, service time for a customer coming through a checkout counter in a retail store is a random variable with a mean of 1.5 minutes and certain deviation of 2 minutes. So that means, yeah, so the mu is the 1.5 and then the sigma is 2. Okay, so the here population is to set all the service time for a customer coming through the checkout counter, right? Okay, and then the suppose that this distribution of service time is fairly close to normal distribution. So it means that population is normally distributed. Okay, so now you can use the CLT. Suppose there are two counters in store, and one is 44 customers. So that's I think a sample size of first sample, and then N2 is 60. That's the size of second sample. Define the probability that the difference between the mean search time for the shorter line is x1 bar and the mean search time for the longer one is x2 bar is more than 0.2 minutes. So they're talking about the difference between two samples, right? Sample mean. So assume that the service time for each customer can be regarded as independent random variables. So we are two samples are given, and then the random variables for uh, in each samples are independent. Then the difference, what what uh, difference of the what two mean sample mean x bar 1 and x bar 2 are is normally distributed. That's what we learned in the last part of SAM point 2. Okay, so second, okay, so x1 bar, x2 bar are the sample means, right? Of two independent random samples. Then the x1 bar minus x2 bar uh, is what is the approximately standard normal distribution. Okay, so now if n1 is greater than 30 and the n2 is greater than 30, that's what we learned. Okay, so but if the two populations are normal, then what the sample and distribution of the what the z-score is also is exactly normal. That's what we learned. Okay, so now let's see. Give me a second. Go to the, let's see. Okay, so let's see. Now, first what we're going to do, we need to figure out all the parameters. Okay, population and then sample 1, sample 2. So that's visual problems. standpoint 1.2. Okay. So give me a second. The problems. Give me a second. So the problem says that what the distribution of service time is fairly close to normal distribution. So it means that the two samples are also the normal distribution, right? Close to normal distribution, we can say that. So the x1 bar, I mean the sample one, for the sample one, okay. So then the mu1 bar, mu1 is the x 1.5, okay. And then standard deviation, okay. Let me just say mu1 bar is, let me just say mu x1 bar, that must be better. This is 1.5, okay. And then sigma x1 bar, that's going to be sigma over what? Sigma over square root of n1, right? But the problem says that the by the way, where does 1.5 comes from? This is what? It's nothing but what? Population mean view. Okay. And the sigma is the what? The population standard deviation. The problem says that what 2.0. So we got 2 over square root of n1. The problem says that n1 is what? The size of first sample is 44. Okay. All right. So now the sample 2, the mu x2 bar, that's going to be also is equal to 1.5 by CLT. Right? And then by CLT, sigma x2 bar is also is equal to sigma over square root of n2. The sigma is 2, and then n2 is what? 60, right? So square root of 60. Okay. So now sample 1, we have sample 2 right here. All right. Then we want to find out what problem says that what the find out the what was give me a second, find the probability that the difference between the mean service time for x1 bar, x2 bar, right? X1 bar minus x2 bar, okay, is greater than 0.2, right? But the I told you the what? So sample 1, sample 2 are the what normal distributions. X1 bar, I mean x2 bar normal distributions, right? And then two random variables x1 bar, x2 bar are independent. And then the difference of x1 bar, x2 bar is a normal distribution. So that is equal to, we find probably that we're going to find the g-score of x1 bar, x2 bar. Okay, because this is normal distribution. So I'm going to find out, I'm going to transform this one to the standard normal distribution. The g-score is greater than what? 0.2, 0.2 minus, so mu1 minus mu2 over, okay, and then square root of what? The, give me a second. Sigma x1 bar. Oops, so this is sigma, okay? Sigma x1 bar square, okay, plus sigma x2 bar square, okay? That's a formula actually, okay? So now, so mu1 is what? A mu x1 bar, right? Mu x2 bar. So mu x1 bar, mu x2 bar is 1.5. So 1.5 minus 1.5, 0. It's going to be 0, okay? And then you can calculate the sigma x1 bar, sigma x2 bar, right? So plug in, I mean, take a square of this guy, take square of this guy, and then put them here, okay? Then using the table of standard normal distribution, you can find the probability, okay? Or you can use calculator. So here. Okay, so right there, the calculator. So what are you gonna do? So we can use the well, we can use the you see go to the distribution. You can use a normal CDF. Okay, so normal in the normal CDF. So the lower, that's the lower and the upper means the lower limit, upper limit of the integral. Okay, so of the what integral of the what probably PDF. I mean, we'll see here point two. So what are you gonna do? See, this is the probability distribution of the x1 bar minus x2 bar. Okay, probability distribution PDF of x1 bar, x2 bar. So we want to find out probability that is point two. Maybe here's a mu1, mu x1 bar minus mu x2 bar. Okay, so point two is right there. Point two. Okay, then that's the what the horizontal axis is the random variable of x1 bar minus x2 bar. Okay, so since the x1 bar minus x2 bar is normally distributed, so the graph, I mean probability distribution of the PDF of x1 bar minus x2 bar must be L-shaped. And then we want to find the probability that x1 bar minus x2 bar is greater than 0.2, which is this. Okay, so we need to find the area of that region. Okay, so that area represents the probability that x1 bar minus x2 bar is greater than 0.2, right? So then how to find out the area under the the graph? So we have to apply the employ the integral, right? Concept of integral. So here the lower limit, lower means lower limit, upper limit. So lower limit must point to right. Upper limit must be what? Infinity. Okay. So infinity, but it's is there's no way to put the the calculator doesn't recognize infinity, so we just put the huge number 99999. Okay, and then mu is here mu1 mu x1 bar minus mu x2 bar, which is 0. The sigma is what? The standard deviation is, in this case, standard deviation is what this. Okay, so square root of x1 bar square plus x2 bar square. Okay, so let me use calculator. So the square root of 2 over square root 44 square, which is 4 over 44, right? So here, 4, give me a second. Here, 4, 4 over 44 plus, okay, and then 4 over 60. So we got 0.307, so approximately we can say 0.31. Okay, so this is 0.31, approximately 0.31. Because problem says that round your answer to two decimal places. So I got 0.31. Okay, so next one. Next problem is a result problem, chapter 7, 7.2.1. So consider a normal population with a mean of 40 and standard deviation of 10. Okay, a random sample of n is 110 was selected. Okay, so the problem says the population is normally distributed with a mean 40 and then standard deviation is 10, and then sample size is 10, then the sample data is given. So find the probability that point estimate of the population mean, which is approximation of population mean, okay, based on another sample n is 70 would be more accurate. So let's see. Okay, let's see these problems. So now, all right, so in this problem, okay, so we need to find out what, definitely need to find out the sample mean of the sample whose size is n. Okay, so now think about sample one. Okay, sample one. So x1 bar. Okay, so one bar is gonna be a sigma xi, right? I goes 1 through the 10 divided by 10, right? Okay, so we can find out x1, and I mean x1 bar, and the sigma. Okay, and then give me a second. See, okay. Sigma x1 bar, okay, that is equal to. So now this is equal to sigma over square root of n 1. Okay, and then sample 2, 2 x2 bar. We don't know this. Okay, we don't know. Do not confuse with x1 bar and then mu x1. I mean, keep in mind this here, mu x1 bar, that is the what? The mean of sample means. Okay. In yeah, sample means, okay, mu x1 bar. Okay. So now the x1 bar is just what? This is just the sample mean, okay, of the sample given in problems with the 10 sample data. Okay, mu x1 bar is a mean of sample means. Okay, so now the therefore this is equal to what? This mu x1 bar is equal, must be equal to what? Mu, which is 40. The problem, why? Because by CLT, the problem says the population normal distributed. Then regardless of what the sample size, the mu x1 bar must be equal to mu by CLT. Okay, so now sample 2, we don't know this x bar 2. Okay, so but the well, we want to figure out that what we want to find the probability that x2 bar is more close, I mean closer to the what, the population mean, right? So I mean then closer to the population mean than what x1 bar, right? So first let's figure out the how close the x1 bar to the what sample population mean. So x1 bar minus the mu, okay, that is equal to um, I think we have the absolute value, right? Because mu is 40, yeah. So or you can just switch them out, okay. That's gonna be what 40. I mean, 4 is 40 minus. I need calculating this, right? Okay, so let me calculate the x1 sigma of xi, I equals 1 through 10. So if you, I already calculated, okay? So adding all the data, sample data, okay, divided by 110, then you will get the 1.38.79, okay? This is equal to 1.21, okay? So now we're gonna figure out this question. There's probably that what x2 bar minus 40 must be less than 1.21, right? Okay. And then also, what if x2 is the less than 40? We have to think about that case. So we have to think about in this cases too. So x2 minus 40 is greater than negative 1.21. Okay. So we need to calculate this. But what x bar 2, this is a normally disputed. Why? Because by CLT. Right? So now then x 40 is also a normal disputed, right? So now we can use the what x2 bar minus 40 is also normal distributed. So we can use the g-score. So this is equal to probability that what? Negative 1.21 over the sigma minus, see, minus mu x2 bar minus mu over, okay, see, and then let me see, give me a second, 2 bar. Okay, I forgot. Let me take a look at the problems. Give me a second. Yeah, by CLT, x2 bar minus 40. X2 bar. The mean of the sample mean is normally distributed, right? So because the sample size of the second sample 2 is 70. So the using this one, that fact, mean of sample mean is normal distributed, approximate normal distributed. So then the g-score of the x2 bar gonna be x2 bar minus 40 over, remember that, over, and then sigma x2 bar, right? Okay, so that's this is gonna be g-score of x2 bar, right? So now we're gonna divide x2 bar minus 40 by sigma x2 bar. Okay, but what's a sigma x2 bar? So here, the sigma x2 bar is what? By CLT, this is equal to sigma over square root n2. Right? Okay. But sigma is what? The standard deviation of the population, which is 10, given problems, the square root 70. Okay. So now, yeah, so give a second. This is, we don't use the sampling distribution of the difference of the sample means. So that is equal to probability that negative 1.21 over sigma x bar, which is 10 over square root 70. Okay. And then x2 bar minus 40 over 10 over square root 70. Okay. Less than 1.21 over 10 over square root 70. Okay. All right. Then this is z-score of the x2 bar. Okay. So what that means? So this one and this one is what means this is normal. It's a normal distribution. Oh, not this one. I'm sorry. This one. This is the normal distribution. Okay. Mission of z-score right there. That's going to be 0. Okay. This is z-score. So when negative 1.21 over 10 over square root 70. I don't know the exact that's decimal value of this one, but maybe right here. And this one is maybe right here. So we're going to find out what area under the bell shape, the curve. That's the distribution of the standard normal distribution. Standard normal distribution. Okay. So now using this table of z-score, you can find out this value, or using the calculator. Okay. So in the calculator, we use the go to distribution. Okay. So distribution, and then go to the normal CDF. Okay. Normal lower must be negative. Say negative 1 point, negative 1 point. You don't have to do this. Okay. You can use this one. Okay. So, or you can use this one, but either one just fine. Okay. But let me see. Let me use this one. Okay. So negative 1.21. Okay. Divided by 10 divided by square root 70. Okay. the upper is 1.21 divided by 10 divided by square root of 7. The mu must be 0. The sigma must be what? Excuse me, sigma must be a 1, right? Because standard normal distribution. So the answer is 0.6886. I think the problem is round your decimal in um, 3 decimal places. So 0.688 must be answered. Okay. So I solved the 3 problems. Um, in the exercise 7.1, covering 7.2. Next time, yeah, I'm gonna cover the 7.3 and 4. Okay. So and then we'll see exercise problem 7.3 and 7.4. Okay, that's for today.